This video is about the base times height method, a method to find the length of some line segments in a triangle. We use the following general triangle ABC with edge length A, B and C. Now, we know that we can calculate the area of this triangle by using base times height times a half, or a half times B times A, or a half times A times B, or a half times C times its matching height H. So the area can also be calculated by calculating a half times C times the matching height. Since it should not matter how we calculate the area should not change, these two expressions must be the same. Now, we can also say, well, if the area of a triangle is equal to the area of the same triangle, then twice the area of the triangle should also be twice the area of still the same triangle. And then we have that B times H should be equal to C times H. If you leave out the equal sign, this spells Bach, which is a nice memory aid to remember that B times A should be equal to C times H. Note that this works because vertex C has a right angle, so B and H are base and height, or base and height. If this were not a right angle, then this method does not work, because then B and A would have different altitudes belonging to them. But for a right angle triangle, this is true. Let's look at an example. Triangle ABC is right angled, and AC is 3 and BC is 4. And we would like to know the altitude belonging to AB, which is CD. Now, we look at the method described over here, and the method says that the edges adjacent to the right angle sides multiplied together should be the hypotenuse multiplied with its altitude. So in this case, the right angle is C, so the edges adjacent to it are AC and BC, and those multiplied together should be the same as AB multiplied with its altitude CD. Now, we substitute all the known lengths. AC is 3, BC is 4, but unfortunately neither AB or CD is known to us. Since these are two unknown values, we have to figure out at least one of them. Well, CD is not something we can figure out in one step, but AB fortunately is, seeing as ABC is right angled, so we can use Pythagoras' theorem. Pythagoras' theorem says that the hypotenuse, in this case AB squared, should be equal to the other edges squared, so AC squared plus BC squared, or 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to 25. Fortunately, 25 is a nice square. AB is the square root of 25, which is 5. So we know that AB is 5. We can use this when calculating CD. We had 3 times 4 is AB times CD. AB, as we know now, is 5 times CD. Now all we have to know is calculate 3 times 4, and then dividing both sides of this equation by 5 gives CD is 12 over 5, or 2 over 5. And now, since we know that this is 2 over 5, we could use Pythagoras' theorem to calculate the length of AD and BD. I mentioned before that this method only works when there's a right angle in the original triangle. But we can make a more generalized version of this method. If we have some triangle ABC, and we have at least two altitudes somewhere, then we can say that AB times CD should be equal to BC times AE. This is also base times altitude, or base times height. And following the same proof as above, this should be true.